Well, hello there. It is KP the Math G. It's a beautiful day today, but today we're going to talk a little bit about applying derivatives of some trigonometric functions. In my last video, we went over all of the derivatives of the 6 trig functions, and so what we're going to do is make some applications. So in our first example, we're going to find y prime, or the derivative of this. If y is equal to sine x over 1 minus cosine x, what is y prime? A lot of times we do this, we need to be able to do it for one thing, but we need to keep our skills, our math skills, sharpened. And so that's what we're going to do here. Now, this is a quotient, so we would apply the quotient rule. Low d high minus high d low over low squared. For those of you who are involved in AP calculus, you understand what I mean by that. So let's do this. We're going to go ahead and bring this up. And so low is going to just come up. So 1 minus cosine x. Alright, times the derivative of sine x. I'm just going to put that dash to show that that is the derivative that we're looking for, minus, okay, now sine x. I'm just going to do this right here. Alright, sine x times the derivative of, let's say, low d high minus high d low. So 1 minus cosine of x, that derivative there. Okay, and maybe I should put this on the outside as well, and then all over low squared. So 1 minus cosine squared, all of that, the whole thing squared. Okay, so now let's continue. Let's find the derivative of sine. The derivative of sine is cosine. So 1 minus cosine of x times cosine of x. Okay. Alright, so minus, alright, and then sine x times the derivative of this. Now the derivative of a constant is 0. Alright, and then the derivative of cosine is negative sine, but since we already have a minus, it will be minus a negative sine x. So minus a negative would be plus, that's times actually. Alright, so sine x times sine x. And that's what that is. 0 plus sine x is just sine x. Okay. Alright, there we go. And then all over, not the y. Okay. And by the way, we'll just say it's equal. I don't like that. I should not use y prime each time. I'm not taking y prime of this. So this is y prime from here on out. Okay, so 1 minus cosine x squared. Okay, now let's do a little bit of arithmetic, and we'll see that we can do a little something with this. So let's see, 1 times cosine x is cosine x. Cosine times cosine is cosine squared, so minus cosine squared. Okay, this is sine times sine, which is sine squared, so minus sine squared. Okay, and then over 1 minus cosine x squared. Okay, I think I have room to put it one more time. I may have to flip the board over, but at least we got it going here. Now, maybe if I could factor out the minus sign here, I would have cosine plus sine, cosine squared plus sine squared, and that is something. So we can probably do some of that. So that's equal to cosine x. Cosine x. Now if I take out the minus sign, I have cosine squared plus sine squared. Alright, so see what I did? I just took the minus out of both of them, So when I take out the minus sign, if I distribute this back, I'll have this back. So minus this would be here, and then minus this would be this. So yeah, we get it back. So now this is a number, and this is going to be 1 minus cosine x squared. Alright, so I think I can do this. Let me write it down so I will have this where I can let's see what we got here. Okay. Okay, here we go. I want to write it down right here. This is, I got so far cosine x minus, alright, cosine squared plus sine squared, alright, over 1 minus cosine squared. Okay, alright. Let me flip this over now, because if I don't write it down, I will forget what I wrote down. So okay, here we go. Alright, good. Here we go. Let's rewrite where we left off now. Oops, I used the pen instead. Okay, bear with me. Okay, now let's do this. Alright, here we go again. Alright, we left off at cosine, this is equal to cosine x minus, now we have cosine squared x plus sine squared x. Some of you probably read this as sine squared x plus cosine squared x. They said, ooh, that's 1. So yeah, it is 1. But we're going to get it right here. 1 minus cosine x squared. A little bit of work involved in some of these. Okay, that's, I know. Alright, so cosine x minus, now all of this is just 1. Okay. Minus 1. All of this. Okay, so that's going to be over 1 minus cosine x squared. One thing I can do, I can flip this around. Okay. Well, I can factor out a 1 or a negative 1, and that will be the same as this. So let me just show you what I'm talking about here. We can say, well, cosine x minus 1, okay, over, now if I want to, I can say this is 1 minus cosine x and 1 minus cosine x. I don't know why I did that now that I think about it. But if I put out the negative sign, then I can make a negative, and I can make this look the same. I don't know why I did that, but anyway, well, it's okay to do it this way. If I put a negative 1 out here, now I've just factored out a negative 1. Now I've got 1 minus cosine x over 1 minus cosine x, 1 minus cosine x. Okay. If you notice, if we multiply this back, negative 1 times 1 is negative 1, and negative 1 times negative cosine x is positive cosine x. Anytime you take out a negative sign, you can just simply turn that around like that. Especially, so in other words, the if I have b minus a, then if I take out negative 1, then I've got a minus b, or equivalently I can just say negative a minus b. So that's where I'm coming from with that. Okay. Well, I have something common. I can take out either one of these. See, I can't take out all of it, but I can take out one each. So now I'm just left with negative 1 over 1 minus cosine x. Okay. Equivalently, if sometimes maybe the negative can come down here, and if that's so, then you can say 1 over cosine x minus 1. And either way, that will work. So that's just putting the minus sign down here. So minus 1 minus cosine x. If I were to distribute that, if I move that minus sign down here like this and distribute that, that's going to be negative 1 plus cosine x, or just cosine x minus 1, and that's what I have here. So if you're looking for a multiple choice answer, you might see this, or you might even see this. So I don't know which one you see, but either way, it's okay. Alright, so that is a long derivative. And by the way, this could represent the slope of the tangent line, you know. Of course, we've got to be careful what x is down here, because x is in the denominator, and if this makes this cosine, if this is 1 minus 1 is 0, we don't want that denominator to be 0. So we have to restrict what we pick for x here. Okay. Alright, anyway, that is the derivative. That's just finding the derivative there. Okay. My wife, I don't know when she's going to be back. She's gone for right now, but she should be back in a little bit. But needless to say, we'll cut it off if we have to. But I would like to do maybe another problem or two. So let's go ahead and erase. Ooh, I bet my eraser's on the other side. Doesn't matter. Yep, my eraser is on the other side. Alright, well, there we go. Okay. After I erase so much, it squeaks a little bit. Sounds like we're on a basketball court. Okay. Alright. Alright. Getting there. Wow. Alright. Alright, that does it. Let's try this one right here. It says, I want to find, alright, the tangent line. Alright, 2y is equal to sine x at x equals 2 pi over 3. This is in radian form. If you wanted that in degrees, it would be 120, which is related to 60. So kind of keep that in mind as well. In calculus, we keep things in radian measure. Alright, so the tangent line, we need to find the derivative. Okay, so whatever the curve is, we're going to find the tangent line to the curve. So we need to find the derivative of this. Okay, so then y prime, if we're talking about the derivative of sine, then that's definitely just cosine. So we found the derivative. That's the first part. And at 2 pi over 3, we have cosine of 2 pi over 3. By the way, this is like in quad 2. So remember that cosine, remember, is the x value. So in quad 2, this is in quad 2, this is 120 in quad 2. Cosine is, well, let's see, 120, well, somewhere right in here. Okay, so we're in quad 2, and then that's 2 pi over 3, which is, by the way, in quad 2, remember the x value is negative, so I believe it would be the x value for cosine is negative 1/2. Okay, and I want to say that the sine, if you wanted to do that, would be, let's see, that would be positive, so that would be the square root of 3 over 2 if this were sine, but it's not sine, it is cosine, so negative 1/2. Okay, alright, always looking for my eraser. A little bit, you have to know a little bit of that unit circle, don't you, to be able to do this problem. Just remember that. Okay, so that's part of it, and then we want the tangent line. So let's see, trying to keep up with my notes here. Alright, so there was a B part. We want the tangent line. Alright, and I was trying to see where my notes were on that one, on that particular problem. And another, actually I got this problem from a book here that I've been using. Just bear with me just for a second. And I've been getting examples from that. Hold on, I'll get there. Alright, tangent line is horizontal. Okay, so horizontal tangent line. Alright, so we already have the slope of the tangent line, but we want the, in this case, this was A part right here. Alright, B part, the horizontal tangent line, if its slope is 0, alright, if its slope, alright, slope is 0, and I think they are going from 0 to, okay, oh yes, the B part, it says what values of x is the tangent line horizontal, and of course if 0 is less than or equal to, if x is between 0 and 2 pi, which is a full circle. Alright, so it says that the tangent line is horizontal if the slope is 0, and that's what is the question is, what values of x is the tangent line horizontal? Alright, the horizontal tangent line, so in other words, whatever the curve is, a horizontal tangent line would be, and it's not dotted, but a horizontal tangent line would be where the slope is equal to 0. In other words, the slope is, we just found cosine x, so the slope is equal to 0. Now, and we're looking for, and so we're looking for this to be between 0 and 2 pi, and so let's see, cosine is 0 at, alright, so let's see where cosine is 0. Right here and right here. So 1 and 2. So this would have to be pi over 2, and then this would be 3 pi over 2. Pi over 2, pi, 3 pi over 2, and then 2 pi. And of course this is 0 right here. This is the cosine wave itself. In this case, y prime is equal to cosine of x. Okay, so right here at pi over 2 and 3 pi over 2. So x is equal to pi over 2 and 3 pi over 2. Okay. And that's it. We're just looking at, well, from 0 to 2 pi. Alright, there it is. A little bit, you might need to know a little bit about how to graph cosine in this particular case, or sine, or whatever. So anyway, alright. Alright. Any horizontal tangent line, it's going to be, the slope is going to be equal to 0. Okay? So just kind of keep that in mind. I did not write the question down, so please forgive me for that, but that's the answer right here. The slope m, which is this, is equal to 0 here and here. Okay. Alright, that does that problem. Might try to do one more, so let me do one more. Okay. Okay. I actually jumped ahead and did actually a third problem. Actually, this is fine. I had another similar problem to the first one, but that's okay. We'll go ahead and do this now. Okay. So you see that there are applications that can be used when we find these derivatives of sine. Well, for anything that we find a derivative of, we can make an application to it of some kind. All right, let's try one more, and this is okay. So I want to find, I don't mind do that sometimes. Find F-I-N-D. Okay, G prime at X. Okay, if G at X, and this is what I wanted to do the first time, G at X is equal to, well, let's see, secant X, tangent X. I don't know why I need to put that there, that's times, and then plus cosine. And that's just finding the derivative like we did on the first problem. Okay, well, we just have to remember our derivatives. G prime at X, then, the derivative of secant is secant tangent. So secant, secant X, tangent X. That's this derivative here. Oh, that's a product rule, isn't it? Okay, so we can do the derivative of the first times the second. Okay. Well, let's rewrite it. I want to do it correctly. Doesn't matter. Okay. Let's do it right, though. And actually, we can do the first times the derivative of the second. That's, it doesn't matter. The derivative of the first, which we were doing in the first place, times the second, plus the derivative of the second one. This is the second, and first, this is the second, plus the derivative of the second, alright, times the first, and then plus, well, whatever the derivative of cosine is. Alright, so we got to deal with that also. That's by itself. Okay, this is the product rule here. Okay, and this is an isolated type, so this is kind of separate from these two here. Okay, the derivative of secant is, now let's put it down, secant X tangent X, or tangent secant, ever how you want to write it. Okay, and then we still got tangent, so times tangent. Okay, and then plus, now the derivative of tangent is secant squared times secant, and then the derivative of cosine is minus sine. Since this is plus, We're going to make this sine, okay, like that. Alright, and if you want to kind of clean it up a little bit, we can do this. Secant x times tangent squared x plus secant cube x, and then minus sine x. And I would not try to change just the sines and cosines and try to fix it up even more, but this is good enough right here. So there it is. The derivative of the first, this is a product rule here, doing this part first, and then this is an isolated problem. I call it that because it is separated by a plus sign. Okay, so this first, the derivative of first times second plus derivative of second times first, and then plus the derivative of cosine. Okay, and that's it right there. Alright, so there we go. And again, that's pretty much what I wanted to cover. So just make sure that, you know, sometimes you're just asked to find the derivative. Sometimes you're asked to find the derivative and then what is the slope at x equals some number. Or what is the velocity, you know, whatever we might want to find. So anyway, we can make several applications to this. Okay, and keep in mind this is a you know, when we take the slope, it's always, or when we're trying to find the derivative, we're talking about a rate of something maybe. So anyway, I hope this has been helpful to you. Of course, if you had a little difficulty following this, you might want to look at my last video where I showed the derivatives of all the trig functions and everything. So make sure you have all that together. Alright, anyway, this is KP from KP the Math G. And again, I hope that you have learned something today. I know I benefit every time I put one of these lessons together. And again, hope you have a nice day. Thank you so much for tuning in.